Hello, welcome to Tech Transform. Today we are here to discuss about what is CAP theorem. Basically, CAP stands for consistency, availability, and partition tolerance. Why we are learning this concept right now? Because in later video I am going to tell you about more of this NoSQL database technology we have, like Cassandra. To get started with Cassandra, first I want to let you know all what is the CAP theorem. So this is the CAP theorem looks like. Basically, once you are working in an organization and you want to choose a perfect or accurate database according to your need, you need to understand this CAP theorem. So this is not a hard and fast rule, but it will 80 and 90% cases it is correct. So let's understand then what is CAP theorem. So you can see we draw a triangle having availability, consistency, and partition tolerance. So you can see how the database sits here. MySQL gives you availability consistency over partition tolerance. Cassandra gives you availability partition tolerance over consistency, and HBase and MongoDB gives you consistency partition tolerance on availability. Why it's always give you in the white papers? Google's and other companies are already proven that out of these three, means out of CAP, consistency, availability, and partition tolerance, you can only get two of the three. Out of three, you can only get two of this consistency. Means you can get only either you can get consistency, availability over partition tolerance, or either you can get availability, partition tolerance over consistency. You cannot get three at a time. That's what the limitation, and that's what already has been proven. Now among these two options available, we have to choose the Cassandra or MongoDB or HBase or MySQL base according to our need. So it's a trade-off between these three options available right now. Let's say you're designing a system where availability of the data and you're actually you have to split. You're dealing with a big data and you have to split your database into different scale of machines, like n number of clusters. You have to deal with that with that type of data. So here your partition tolerance is not negotiable, it's very necessary. So you have to deal with the big data, you have to split up your data across different scales of machines. Then only options you have left is among between consistency and availability. Now you can you can do trade-off. Let's say if you are let's say you're in a Facebook and you're posting some messages or anything. So if it can take 3 or 4 seconds to just replicate over all the entire system, then you can go with the consistency, because availability you can go with the availability. Why? Because if you have availability, your database is never going to down, it's always up. So that's what, if you want your business to be not affected, so you have to choose availability over consistency. Consistency in some sort of scenario, like in banking and stock market, your consistency is very important rather than having availability. Means you're buying and you're doing transaction, you want immediately the results to be affected across all the nodes, and to the user you want the immediate results to be reflected. That's what where you have to trade off between availability and consistency, and where the consistency will lead. So in order to do that, you can choose these two, HBase and MongoDB. Let's say you're not dealing with a big data, you're dealing with a very small data. It's MySQL or Oracle, and your availability is always important, consistency is always important. You're not dealing with big data, so there is partition tolerance you can neglect. So these two will be work for you, availability and consistency. In that case, you can go with MySQL and Oracle database. Let's go each one by one. What is C, A, and P? What is CAP? The CAP theorem states that a distributed database system can only guarantee 2 out of these 3 characteristics. Means out of consistency, availability, and partition tolerance, you will be getting only either consistency, availability, or availability or partition tolerance, or partition tolerance and consistency. What is consistency? A system is said to be consistent if all the nodes see the same data at the same time. Let's say I'm doing some records to write. I'm writing some records to database, and at the same time, if your system or database is consistent, all the nodes see the same data. User will see the same data at the same time, just after a write. Simply, if we perform a read operation on a consistent system, it should return the value of the most recent write operation. Means what is the latest record you have, latest value you have, that your system should show. That means you're having consistency. Consistency. This means that the read should cause all nodes to return the same data as the value of the most recent write. We understand now consistency. Let's move to availability. Availability in a distributed system ensures that the system remains operational 100% of the time. There should be no downtime. Every request gets a non-error response regardless of the individual state of a node. So if your simple state a node is also going to fail, but your systems would be always available. That's what we are dealing with Hadoop and all those systems. Note, this does not guarantee that the response contains the most recent writes. So if you are going with availability, that doesn't mean that you're not going to get consistency. There should be some delay in getting the latest data. The last one is partition tolerance. If you're dealing with a big data and you want your data to be split up across clusters, so this options become non-negotiable and you have to go with this partition tolerance. There is no other options. This condition states that the system does not fail regardless of if messages are dropped or delayed between the nodes in the system. Means partition, if you're dealing with a big data or the Hadoop architecture or Spark architecture is like that, if any, it's because they are very resilient. So it's a partition tolerance. You won't face any type of difficulty if any node goes down. Partition tolerance has become more of a necessity than an option in distributed. If you're dealing with the distributed systems, that this is not an option. This is the this is non-negotiable item. You have to go with that. It is made possible by sufficiently replicating records across combinations of nodes and networks. So in last, if you're dealing with a big data, that's what I already told you. Partition tolerance is a requirement with a big data. So you really only get to choose between consistency and availability. Means you have only two options. If you're dealing with a big data, you have to have partition tolerance. Your system designs would be like partition tolerance. Then you have to deal with only, if your partition tolerance is non-negotiable, you have only these two options left. So either you can go with Cassandra or either you can go with HBase and MongoDB based upon the requirement. So in some scenario, if you delay sometimes to get your write to take some time, so you can go with the availability, because Cassandra provides you always up 24 hours. There will be no downtime. But if you require only consistency over availability, you should go with HBase and MongoDB. So in my later video, all others NoSQL database chests tools are based upon this CAP theorem. So that's why I told you what is a CAP theorem. So that's all for this video. Thanks for watching. Have a good day. Bye.